Okay, we have about 180 people now. So you can see here on the screen and how many people have seen these various technologies. I had not seen Azure Machine Learning Compute until I did it for this lab, and maybe I've seen it in the presentation, but to me, it's one of the exciting technologies now that will enable you to do distributed data science, which is what we want to do. We want to be able to do many models at the same time. And for so many of us who have been coding on laptops, and my last large laptop that I bought was a 32 gigabyte machine. I am not going to buy any more large laptops. I'm going to have a good laptop, but I would prefer to run a lot of these workloads in the cloud. So let's go now to the presentation. I'm going to go going back to showing the screen. Let's see. Oh wait, I have to turn on the poll. Hide the poll first, and then I can show two, and let's see what you're seeing. Yes, you are seeing the beginning. Okay, great. So let's launch into this presentation. We hopefully will have some time for questions and answers at the end. I anticipate that because of the number of attendees today, I may not get to all the questions and answers. So my plan will be to answer any questions in the slide deck, which will be shared. And by the way, this recording will also be shared on YouTube. So we'll have the chance to do that. And plus, I will be able to stay longer than the hour for Q&A if folks want to hang on. So at a certain point, we're going to cut it off. But we are going to go into this presentation. Who I am, Mark Tabladillo. I have a doctorate from Georgia Tech. I'm based in Atlanta, Georgia. My analytics career has been based on SaaS, Microsoft, open source. I've been in the past graduate business faculty, tech presentations I've done in many cities around the world. I'm on social media, but what so many folks here from Microsoft, I am a cloud solution architect now in the US CTO customer success area, which means I am now pre-funded. I work with clients. I'm client facing, work from home, travel to clients up to 30%. And typically, what I do is build solutions. So today I'm showing a demo, but on my regular day-to-day work, I'm building solutions. I'm helping our pre-qualified customers get started, and especially in my area of knowledge, which is data science. And I'm involved in about 5 things right now. Next week, I'm going to be going out of town for a 2-day hackathon, and it's where we're going to join some other architects, and we're going to help them build some solutions. So that is what I do full time. Going into this deck. Okay, now some of these slides are from our standard slide decks, but this shows kind of the idea why Microsoft's making an investment. We believe that there is going to be a huge market in the area of AI. It represents a growing opportunity. And what's important here is what the money is going to be spent on. And this is from Gartner. So we see the decision automation, smart products, virtual agents, and decision support. Those are some of the ideas. We're just telling us now, where are the analytics capabilities now? Where are the top competitors now? And where's that going to be in the 24 to 36 month period? So what we're seeing is that from basic on the left to advanced on the right. And this audience today is probably going to be at the leading edge. So you're going to probably be more toward the advanced side already and may have been there for many years. But we're going to see organizations trying to drift here. And I know a lot of people who are attending today are going to be that voice piece in showing people the value of analytics. Now, this is what I'm going to call my money slide. I put Ben Franklin on top of it. And, I altered it, a slide we use internally to Microsoft. What this slide shows is 6 specific columns here and some ideas of how people are using data science or modeling. And there's a link here, and again, it's your QR code. It's going to go to our AI website. The reason I put the dollar thing here is because people wonder where the money is in a data science career, deep learning, some of these high technology, advanced analytics areas, and they always really need to come back to a project. If they don't come back to a use case here, nobody's going to pay for it. Nobody's paying to train models in with sci-kit using Azure. What they're going to do, though, is they will pay for predictive maintenance, or they will pay for sales insights or product recommendation. So just keeping that in mind as the big picture. Okay. Now, Microsoft solution has a value prop here for advanced analytics, and it is based on our data story. So we have data modernization on-premise. We have technologies like SQL Server, data modernization to Azure. Now we have so many data technologies, not just SQL Azure, but also hosting other technologies on Azure, and also Cosmos DB, globally distributed data, which is made possible by the Azure Data Center, and then cloud scale analytics. On the right, we have AI apps and agents, knowledge mining, and the area of focus today is machine learning. So just giving you a map here of where we are on this entire map. There are other technologies and solutions behind these other ones, and they are for other presentations and other days. Now, looking at our portfolio, we do have some pre-trained models, and those will be surfaced through cognitive services, typically trading JSON, and very friendly to developers. They're in the area of vision, speech, language, and search, and you can see what those are. Again, that's not the focus of today. We have also familiar data science tools available, and you may run PyCharm, Jupyter, VS Code, Visual Studio Code, command line, and including bash scripting. And we also have popular frameworks, PyTorch, TensorFlow, scikit-learn, which is where we're talking about today, Onyx for another day, Azure Databricks, and that's for another day. Azure Machine Learning is for today. Machine Learning VMs is for today. And we're also running on CPUs today. And that's what we are talking about. So we'll be talking about the Visual Studio Code. Okay. And the goal here, now we're not talking about deployment today. I'm going to call it out that we do think about that. I intend to have other future presentations to talk about that topic, but today we want to talk about training. And we want to talk about the automation. So there's some this automation is going to be referring to something else that I'm not showing today, but we're going to look at the managed compute today, and tool agnostic Python SDK, which is what we use to connect to the Azure service. So we have CPUs in different series available. We're going to see which ones I'm going to spin up. And again, deployment is not a focus of today, but there is a deployment story. Now, this chart I find is useful because the first row refers to big data solutions, second row refers to data science. Today we are in the second row, and we're going to see data prep, and we're going to see it done with pandas. That's what we're seeing today. And today we're also going to see here training with Azure ML Service. We are not seeing deploy today. And also there's other boxes we are not seeing today. We're not seeing in this entire row, but I'm showing this because let you know that there are other rows. Azure Global Infrastructure. So if you want to shoot that code right now, I'm going to go to that. Let's see if I can make this smaller and bring up the screen. No, it's not going for me, but it's always hard to know what the browser will do here. Okay, the important thing here is that this global infrastructure is going to show where the Azure centers are, and more importantly, it's going to show products by region. Why am I showing this? I'm showing this because technology we're talking about today is not available in every region. So it's going to be only in certain regions, and this is the place where you find out where it is. And we're down here in the AI and machine learning category. You can see what the different technologies are that are available. We're talking about Azure Machine Learning Service. This is new. This is not Azure Machine Learning Studio, which you may have seen in the past. I decided to run mine in South Central US, which is Texas. And of course, you can see where some of the other places are. The dots mean it's currently there, and the other areas means when it will be available. Of interest, perhaps, to folks who might be in regions where they need to run, for example, in a country. I had a Canadian client that could, wanted to run in Canada. So of course, they'll have to wait for that to be available Q2 2019. So it's pretty soon. Okay, that's what I want to show there. So let's go straight to the demos. This is our architecture today. What I did with the architecture is put numbers on it. I like this as a best practice because when you're showing it, especially to new people, you show them a diagram like this and they don't know where you are. I mean, you see arrows going everywhere in widgets. So let's start at 1. 1 is going to be a data science VM, which we're going to do in Ubuntu. And then we're going to send code later to Azure Machine Learning Service. This is going to be a web service. It's going to show in the Azure portal. And the importance there is that that's going to be the central hub for then launching the compute and also managing the storage blobs and the container registry. So that's number 2, and 2 is going to be monitoring 3, 4, and 5. And as all the status, see the status arrow here going from the right to the left is going to come back to Azure Machine Learning Service and store it there in the portal to show kind of the status updates and what's happening. Independently, these gives the ability to spin up these other nodes on the right and run workloads. That's the idea. So this is where we're going to start on the left. Python sci-kit, we're going to launch it here, and then we're going to do it here. But actually, in the beginning, we're just going to run it locally. In this demo, it shows how to run locally, and then later on, use this service to run it distributed. Well, it's actually not distributed. It's going to be multiple nodes. So I misspoke there. What I mean by distributed is it's going to be on many nodes, but each node's going to be a single process running on those machines. So I did misspeak there. From this setup, or the way this lab is constructed, it's done with this virtual machine size, and the setting was to 16 nodes. Okay, now here's the 2 QR codes for the documents. Now this is fully documented on the Microsoft website. So the one on this QR code on the right, this is going to be the description, and then the one on the left, this is the GitHub repository. So right is the description, left the GitHub repository, and that's where we're going to be. So I think I'm going to go straight to my Linux VM. So let me bring that up. So what we are looking at, I'm running on a computer, it's got Windows 10. So what I'm connecting to is an Ubuntu data science virtual machine. It's already been provisioned, and in fact, all the examples I'm showing today are already run. Unfortunately, we do not have time to run them live. I do like to do live runs, and I may do some limited today, but I'm not going to be able to do the whole thing because it takes over an hour. In fact, it almost takes 2 hours. So, but you can follow behind and spin it up yourself and go through all the clicking, and I'm going to show you exactly how to get there. So this data science virtual machine, this is already pre-populated, and if I click down here, you can see some of the things that are already in this data science virtual machine. We got Julia's already in here, and PyCharm is here, RStudio, Weka. There's so many things already here. You can explore it on yourself. Also in this should be SQL Server 2017. I know I saw it in the list, but I don't know that I saw it on the menus. But it said it was on here, so I'm going to trust that's true. Okay. So going to the next screen, let me go to this is the GitHub repository, and this is the code for this demo. Now, I did not write this demo. but I'm showing it. And at the end of the demo, I'm going to suggest some modifications or some other things to try. So, ways that you might want to modify it or tailor it to your own use. So the application flow as follows. Create an Azure ML Service workspace, create a cluster, upload training and test to Azure Storage, configure a hyperdrive random parameter search, submit the search, monitor until it's done, retrieve the best set of hyperparameters, and register the best model. And again, the goal today is just training. So we're not going to see scoring, we're not going to see deployment, just letting you know expectations. These are the directions. And the first thing one does is create a Linux Ubuntu DSVM, which is what I did. And then you clone and fork or download the zip file for this repository. Now, what I did is I used Visual Studio. So if you go to Visual Studio, and this is VS Code, and it's running inside the Linux box. So it's already there, and also terminal, you'll notice here is on the bottom window. And what I had started doing was I started using the native terminal, which is here, terminal emulator, which I think is X-terminal. But you know what? It didn't cut and paste. I don't know why. It's supposed to cut and paste across the X2Go interface, but it didn't. So then I said, well, forget X-terminal. I've seen you for so many years, and I'd rather be in VS Code anyway. So since I was going to show it, you can just use VS Code to be your terminal window. Just be aware, later on I'm going to launch Jupyter, and if you close VS Code, it's going to close your Jupyter session because it's tied to the terminal window. So that's the location of that. So you can do the git clone. Now I already have done it, and I'm going to show you what happens. This is my home directory, and I have a different view here. So the view that is default is an icon view, but I like the other one here, detailed list, because it gives you sizes, and it's also the same type of view I like on Windows. And so what it did is it copied the Git repository, and what you see is, and this has already been done. So in the beginning, there are no folder. All these folders are not here. But what you do get is a lot of these files, and you can see some Python files and some Jupyter notebooks that come with it, and also this environment YAML. That's what comes with the GitHub repository. Now, what it wants you to do is conda environment create environment YAML. So to be able to do that, you do need to be in that directory. Now, it does not make that clear here on this statement. So if I had just opened the Visual Studio window and I had created or cloned the archive here, then the second command, which actually is what I did, I just ran the second command and said, well, wait, environment YAML is in the other directory. What is environment YAML? All right, so let's take a look at it. So I'm going to right click here. I'm going to open it with Visual VS Code. And what you see it does, this is going to make a conda environment. It's going to give it a name, and it's going to also it has some dependencies on packages that need to be in there. Why is this important? Because later on, we're going to be making a Docker image, and we need to see that the versions are the same. This is one of the areas that's going to drive you crazy if you don't know how these things are made. So I know if you just run the demo, it's like, well, where was all this specified? Okay, it's specified in this environment YAML file, and that's what the important thing is. Now, this is going to ask you to install and enable Jupyter widgets, log into Azure, set your Azure subscription, and then launch Jupyter Notebook. So I think my Azure subscription should still be on here. I'm going to do a refresh just to make sure. Okay, so it is still on, and I'm now going to go to here, terminal window. I'm going to CD to the M. Well, actually, just do analysis first. And ML hyperparameter tuning. So I'm going to CD to ML, type tab, and then go in. I love tab because tab's my name. But anyway, and then Jupyter Notebook. Okay, so it's going to launch from that directory. And like I said, it's tied now to that terminal window that's inside Visual Studio. There are 5 well, actually six notebooks. They started at 0, like every good computer scientist, going to start at 0. And the first one here is data preparation. So now this part of the demo, we're going to read through these 6 notebooks because these 6 notebooks have the entire story. We do not need to do the last one. The last one's going to tear down the environment. I never ran this, and I'm not going to run it today because what that would do is that would take down the resource group that I made on the Azure portal. So we don't want to do that. I will do it later. In fact, I may not do it at all because for next week's hackathon, I think I'm going to show this. I may need to show this demo again, so I might just leave it there. But right now, we're just going to go through these 4. You can see it's going to be data prep, the names of them, training script, run locally. So first one's going to make the script, and number 2 here is going to run locally, and then we're going to do hyperparameter search. This is the one that takes an hour and a half. And then the hyperdrive run recovery, what that does is takes the best model and it puts it into a pickle file. So that's going to be the end of the output, and then all the output you'll see here on the screen. So let's go through what is this lab about. So what this lab is about, this is going to be a text analytics problem. And the problem is to take questions from Stack Exchange that include original questions tagged as JavaScript, their duplicate questions, and their answers. And the goal, and I try to figure, it wasn't really clear to me what the use case would be, but I think the idea is, trying to find, as you know, if you've used Stack Overflow, you sometimes see the same question asked again and again. And on the surface, I think this is a valid problem. But sometimes people ask questions again, and maybe you're that person hoping that there's a new answer. So, and sometimes it might be true. I don't know. I mean, if you would have asked 10 years ago, does SQL Server work with Python? The answer was no. And if you ask it today, the answer is yes. So, it's a valid question to look for duplicates though, because, obviously in a highly trafficked board, people may come in with a question that's slightly worded differently, but really is the same question. So that was really the matching exercise. It is a dummy exercise. However, I think the solution here, my opinion overall is pretty elegant. I think it's elegant. Those of you who are text analytics experts might differ with me, and you're free to, share your opinion with me on Twitter. We can have a conversation there, or on LinkedIn. So anyway, what we're talking about here in this first one, we're just using OS and pandas. There's a text utilities package. I didn't get a lot of detail on this. I started looking for documentation. I couldn't find it quickly, and then I moved on. But at the beginning here, we have some parameters that will be set. There's going to be an output path, which is the location of the data files, and that's going to be this particular part of code is going to download the source data from a blob. This is a Azure storage location, and these gzip files, which are already up there in the cloud, they're going to read them, and then they're going to show what some of the questions are. So you're going to see the beginning of questions here. One says get client MP using JavaScript, stop set interval, colon JavaScript, and also it comes through with the HTML tags, which is part of the problem. So we have dupes, duplicates, and we have them. By the way, there are answer IDs that are uniquely keyed, and also there's going to be IDs for the questions too, which is going to enable you to match them later. Here is an example of a question without any cleaning, So you can see here that, you have the slash to show, it's like a delimiter for that single quote. And then you also see some HTML also embedded in here. And now this is going to say, let's check for the duplicates of that question. So we can look for the duplicates. This has to do with, then beginning here, the text, monitoring HTTP request header on a page. How can I read the current headers without making something? How to access HTTP response headers? How to read HTTP header values from JavaScript? So it keeps getting asked over and over again. In fact, look at the dates, 2010 and running all the way 2016. People have been asking for 7 years. So the answer to the original question, unfortunately, there isn't an API to give you the HTTP response headers for your initial page request. That was the original question posted here. And then it goes on to explain it. All right, so I'm not going to go through that right now. We want to focus on what the Azure ML parts are. There is some data cleaning here that happens. One of the data cleanings that you see here is to take out the HTTP tags and also make it into lowercase. And what I like here is they do some checks. At different points, they're doing checks and they have these raise exception codes. I like this as a best practice because it shows you sometimes you run code again and you didn't think of a case, and it needs to be, taken care of. What is happening here in the cleaning is they're getting rid of duplicates. Sometimes there were entire duplicates in a row. One thing I thought about in the duplicates is sometimes duplicates happen because there's different versions of the same thing. So there may be a unique question ID. However, in the backend database, there may be different versions, and one version may have more information than the other. That question was not answered for me on this page, and I'm not saying that it did happen, but they just took the first one here. That's what the keep first means, and then they moved on. So what happens is they now have a data set with questions, answers, and duplicates are here. And then we're moving on. Verifying the data integrity. They do some more cleaning. They get a restricted data set. And then from this, they prepare a training and test set. So I'm not going to go into all the details here. I did read through this, and you can see the results here by running it yourself and seeing what the results are. So what happens at the end is that we're writing data sets, so you can see how many rows were written and where they went. They went into this data file. So again, we download from the web, we're in the data file. So back here in this data file, this is where the data is stored. You can see the larger sizes here, 200 megabytes. And that's just the idea of how big they are. I also like that Jupyter here, putting a link here to the next one. And this is a good thing to do when you have a series of notebooks. You can just click the next one, you go to the next script. So next one is going to make a script. Now, if you notice what it does here, this %% whitefile scripts train test classifier.py. What this Jupyter notebook is going to do is it's going to start building a Python file. And what's important, as it says here, is that you have to have blank lines at the start and the end of the cells. So if you notice here on line 2, you notice how there's a blank line before the code and a blank line after. If you don't do that, it's going to put it next to the end here, and it's not going to have the carriage return. So that's what they're saying. That's why you got to put the blank line here, the blank line there, just to make sure that there's a buffer. Again, best practice. So don't be surprised, because Python, is finicky. Column does matter in Python. And what they did in this Jupyter notebook, they're showing you the sections, but then, this all could have been done as one cell, but what they did is they're just showing you, all right, this section is loading the libraries. This section is defining utility functions and classes. Now, nothing's running here, it's just building a Python file. And then it's talking about the input parameters here for how many runs. We're going to start getting into that. There are ranks in here, and loading and preparing the data. Defining the featureization and estimator is the next section. Training the model, scoring, and using the test data, and reporting the model's performance. And so that's what all happens. Now, what actually happens right here is that this runs right in this virtual data science virtual machine without using Azure Machine Learning Service. So what this is doing one run, and it's setting some parameters. You can see what their parameter settings are. And then it shows the output. And actually, the way to read this is that the accuracy in this model is 64.49%. That is our baseline. Now, this is just done with one set, and the question is, can we beat it? And that's why we want to use Azure Machine Learning Service. Can we beat 64%? So the first one here is called an Azure ML local run. So let me explain what that is. What that means is the code is going to be run here, but the results are going to be saved to the workspace. And that is that's a scenario that I actually have seen in real life, and that the use case was that this particular organization could not have data in the cloud yet because they didn't have policies in place. So we were doing Python training on our local machine, and now in that case, I was not using Azure Machine Learning Service, but I did research it, and I knew that there were some features of Azure Machine Learning Service that we could use where data would not pass to the cloud, and which is what we wanted to know. So there is a way to do that. I did put a subscription list in here. This is my subscription, which you will not have access to because you cannot, even if you see it, doesn't matter because you can't log in as me. So that's just a subscription. And then it's going to make an Azure ML workspace and an estimator, create an experiment, submit the script, and then get the results. Now I'm going to go to the cloud. I'm going to show a few things. First, I'm going to show the Train Python resource group. This is where I made my data science virtual machine, which is here. And you can see also traffic that's happening right now because I'm actually using it. And we do different things with that. And going back to resource groups, what it does make is a hype tuning. It made a new resource group called hype tuning, and it put some artifacts in here, including this machine learning service workspace. Okay, and this is where this first one here is where it starts saving the results. Now notice it says experiments. Now what is new here, this is what's different from Azure ML Studio. It's got 1, 2, 3, 4, 5, 6, 7. We're not going to see all of these areas, but we're going to see some of them. And the experiments is where we are. And this, of course, has already been done. But I'm going to go into number 1 to show you what a result looks like. This is a 64% model. Why is it 64? Because it's the same model that was run locally. So it's still that baseline 64%. Oh wait, I clicked off the button. Sorry. Navigation error there. Not where I meant to go. So I was meant to stay here at 1 and go to outputs. Then logs. And the logs here, this log that shows in Azure ML Service, if you compare this log with the log I have from this local run, actually it was this one right here. This is the one that ran completely on the data science virtual machine. Then the second notebook ran it in Azure Machine Learning Service, and you see the log went here. So it's what it's showing, this is just one run, but what it's showing is the idea of what's going to happen when we spin up more machines. So let's do that. We want to see the machines. Come on. So the next one here, hyperparameter search. And I'm not explaining hyperparameters today, but let's just say that there's many ways to run models, and you can go through, and let me go down here. First of all, let me call out the 16. So right here is where you called out 16 max nodes. This is what it says, and this is what I use. So that's the default lab, and then it shows here 16, max node count 16. Uploading data to the cloud, and what happens is it will be uploaded, and it's going to go into Azure Blob storage. And I noticed in my case, when I was uploading it, there seemed to have been some sort of error that happened to me. However, it recovered from that error and uploaded all 5 files. what 5 files. I just showed them a second ago. These are the 5 files that were earlier made to run locally, but now they're being uploaded to the cloud because now we're going to run them on Azure ML Compute. They give a table here to try to show how many. I think this table, it doesn't say here where this table came from. I assume it came from running it themselves, lab author, Mario, and maybe team. But the idea here is that if you want to get more juice, you're going to have to try more combinations. And this hyperparameter space, so here is the hyperparameter space and the range command. So like this first range, 1 to 5, means 1 less than 5. So it could be 1, 2, 3, 4, but it cannot be equal to 5. So there's 4 combinations there. That's 4 n-grams times 39 times 30 times 2, which is a grid of 9,360 combinations. Now notice this one went to 8,000. So you'd have to go for more. But right now, just for the purpose of this lab, this one was capped at 96. So 96 total runs is what I ran. All right, this estimator here. Now, this is beginning of the building of the environment that's going to be used inside the runs. And remember earlier, I talked about this environment YAML file. Notice how it's specifying packages again. So why is this important? Packages need to match. This could be a deep place where an error could be and why something doesn't work because you did it one way and then you did it another way. So just making sure that the package numbers are correct, or at least consistent. There's no such thing as correct here in this context. It's about consistent. Okay, the Azure ML technology for doing this is called Hyperdrive. That's just a name. So I popped into that cell. And run the search. So it's going to run this experiment. It's going to call it hypertuning. And while it's running, all this whole thing, shows in process until it's finalized. So you can see the final results. And you see the wall time here, 1 hour, 22 minutes, which is how long it took to run the whole thing. Okay. And that's what shows. So, and then there's a wall minute here, 12 minutes just to grab the answer. Let me go to the web portal, and then I'm going to show that. So now we're going to go back to hype tuning, back to the experiment. And if you notice here, 1, 2, 3, and then 100. All right, where's the other numbers? So all of them were actually number 2. And 2 was a bundle of activity, and so that's why there are no parameters here. But if you click into 2, what you will eventually see is this graph filled out. So this is a chart, and these are all the runs. You see 0 on the left and 100 on the right, and the accuracy parameters here from 0.56 or roughly to 0.74. So just scanning across here, you can see where a lot of them are landing here. Now, remember the baseline was 64. So actually a lot of these runs just happen to be larger. And maybe it was just bad, choice of initial parameters. But the highest one actually was run 87, which is here on the right, and it's 73%. And if I go down the list, you can see all the runs. And I go down to number 87, and find, in fact, let me read what these columns are, because this column here has durations. Run 4 took 13 minutes. Run 5 took 13 minutes. In my case, it brought up 12 nodes. I never reconcile why there's 12 nodes for me and why it said 16. So I didn't get to the bottom of that. But it was roughly the same, so I was satisfied. When I saw the actual number of nodes that were deployed. If I go to number 87, it shows me an accuracy of 73%, and then logs. You can go into logs here. Notice there's a download button, so you can still download the logs. These are like progress logs. So for the really deep geeks that are in the crowd, you're going to be able to get a lot of metrics behind what exactly happened here. And then this is also the output, which was programmed to print. This is just a Python print command. And so that also shows here. So whatever you want it to say, it will say as part of the log. And that's what that is. So at the end, going forward, next notebook shows how it recovers the information. I didn't call out earlier that in the beginning here, you're going to see this from Azure ML Core, Azure ML Widgets. There is an Azure SDK. It works with Python. That is the path to access Azure through using Python and the Jupyter Notebook. And of course, that was already added into the data science VM, so you didn't need to add it. I noticed that it was not mentioned on the original program sheet, so that should have been or could have been there. So that is the best run. Now, I'm going to go back to the deck. Okay. While it was in motion, I took this picture, and this picture showed cluster core quota reached. And I'm not fully sure what that means, but I did see that there were 12 nodes running during the hour or so of my run. And then as it was almost done, you can see the number of nodes were dropping down. So that's what you should see. Like right here, it shows one is leaving, one last one was still running. So that's what I have there. And then this shows some of the network traffic on the web portal. You can see traffic on the data science virtual machine, what it does, some of the traffic for the Azure Storage Blob. And of course, remember, I had to ingest a certain amount of data, but notice the egress. So the egress numbers are big. Why? Because the numbers are sending data to each of these nodes, right? So 96 runs, you're going to take that original, what was it, 200 megabytes, and you're sending it to these nodes, and that's why that number is higher. Okay, so I'm going to talk about some of my mods and hopefully get some of your questions. On the ETL, I would consider personally using SQL Server, which is already in the DSVM. It already works with R and Python instead of just using straight pandas. And the reason is, I thought, by the way, I put this MVP. I know some people might be in the MVP program. I think it's a challenge if you have an MVP to add your own modifications when you do a presentation. So I was part of the program for 7 years. And these are some of the ideas I have to modify the lab as is. I left it as is for the run, but these are things that I would think about if I were doing it for clients. Thinking about SQL Server 2019 in preview, that's going to have Kubernetes pods, a very exciting technology for another day. We'll talk about it. Works with Spark, HDFS. The data to keep, they had a hard cutoff at 154 characters. I didn't show it, but some of the answers were as small as 1 character. And I would have wanted to know, what are those? What are those 1 character answers that are coming out of Stack Overflow? And also, I was not sure about the use case and personas. It's just a question. It's not a driver, but it's often important when I'm building a solution with a team for clients. We need to know what that's for. I'm not sure about the ranks. This project was based on ranks and as a way to find out what the probabilities were. And I didn't wrap my mind fully around that, but I would have liked to look at something else or a different way of analyzing the accuracy. I would want to explore also with more nodes. I think a lot of us would want to do that, add just, bump that number up from 16 to a different number. What is curious though, I knew I was going to do 96, and I don't know that, for example, if you could do 96 nodes, that it would be less overall time. The reason being because when a node starts, it's cold. So the question would be, how much advantages there, what are the specific mechanics in running a node and keeping it open for successive runs is a question I didn't fully answer myself. And then also one is about estimators and algorithms. A lot of times when we're training models, a lot of data scientists are not necessarily super concerned about performance. So again, that's not a super critical issue. It is, performance is obviously more of a concern on the deployment side, especially in scoring. So Microsoft unique differentiators. So we talk about our differentiated value proposition, as far as cloud, and 90% of Fortune 500 companies using that. Here are some education or training links. Again, this deck will be available. The one on the right is going to be Microsoft Professional Program, free. Microsoft Learning, a lot of free stuff. Of course, you would have to pay to be certified, but there's a great value in doing that. And then a lot of free videos on Channel 9 if you just want to surf in there. Pointing this out too, because a lot of the videos will not show up in a search engine necessarily. I mean, a lot of times you'll see YouTube, where Microsoft does also share a lot of videos, but there's also unique content in Channel 9. Many of these companies, this is a list of companies that are using Azure ML for ML and AI. So these are just a list of companies all around that are using this technology. And finally, my picture with my social media, links there. So let me try to pop out this question bar here. All right, I have a few questions. I'm going to try to find this. Let me see. So first question here, used to find lowest cost or maximum profit in a business problem. Has the technology been replaced to a large extent by AI? That question, I would think, well, first of all, AI is not going to replace any specific technology, because I feel like even Python and a lot of the technology we have here still require human intervention, if that's the nature of the question. However, I think as we go forward, we're going to see people leveraging AI to be their assistant. We're going to see data science bots that are going to help us doing the modeling and a lot of processing. So I know the way they're teaching modeling today is important, but it does remind me of, learning calculus, or when I first learned algebra. A lot of the type of things to understand the mathematics are different from what someone actually uses in actual practice. So that's perhaps the way I would answer that question. Okay, are the Jupyter notebooks available? The answer is yes, and they are in the GitHub repo. And in fact, go to the entire GitHub repo. The link to that will be in the deck, and the deck will be shared, and you will see the link for all people attending. Okay, someone answered my quota error. It displays when your Azure subscription has not been allocated enough maximum number of cores for a specific VM type. If you would have to ask support for increase your quota to 500 cores. Okay, well, thank you for that note. But I'm still answering the question, because I think mine was set to 100, and it seems like it should have been enough to go to 16, but that could be the entire thing. But I'm thinking about it now. Maybe it has to do with the core. So 4 times 12. No, it still doesn't get to 100. So even if they're 4 core. So I'll have to study that. Okay, someone asked, how can this be automated? Can you point us to some documentation? And the answer is yes. The automation would come, I would look at the technology called Azure Data Factory, which is our orchestration technology in the cloud. Let me see if I can do a link. I can do a link. So look at Azure Data Factory, which these days now is beginning to merge with an on-prem technology called SQL Server Integration Services. So this technology would be what one would use to schedule jobs and or have jobs that were triggered. As far as examples, you could find examples by looking at the reference architectures inside the Microsoft documentation. But what was more important is first just to understand what it does. And I did give a link earlier to Channel 9. If you want to see a video on Azure Data Factory, go to Channel 9 to see what this does and then how you might be able to use that. Okay, score.pies and init cannot load the model. Do you have any suggestions? I don't have an answer for that question. How do you automate the gather data, data modeling, wrangling, feature engineering using ARM pipeline, CI/CD speed up this part? Okay, so that might even be the same question. Again, going back to Data Factory, I think Data Factory can be used in a lot of things for production. We are going to be talking about some other answers later on for deployment. So, look forward to presenting future sessions that would touch on those topics. Okay, someone says I use Azure Portal to create the image and then to deploy the app to ACI, so Azure Compute Instance. And so that's a way to do it. I did not show images. I'm assuming you're talking about the images that are in Azure Machine Learning Service. We did not see that today. How can we get pricing done for Jupyter notebooks? It is all about pricing associated with the Azure storage and nodes, which are running in the background. So the pricing, so I'm assuming that's a question about the pricing for this technology. The pricing is based on using the service, also storage in the blobs, and also that data ingress, egress would be part of the cost. And there is an Azure calculator. So if you just look for Microsoft Azure Calculator, again, let's see if I can find it quickly. Cost pricing calculator. Okay, now this is only going to do a rough estimate, but it is what myself and so many architects use as a starting point in estimating how much things will cost. Okay, someone said, can you comment on AutoML and choosing the right estimator algorithm? There is a technology called AutoML. It will go through and try to figure a best algorithm. It is not something I showed today. It is something I would encourage anyone here who's got a career as data science, if you want to look up AutoML and find out what Microsoft's doing with that right now, that's a good follow-up exercise, not out of scope for what I showed today. But certainly very interesting now for what people are doing. There's an AutoML package, and it is stepping in the direction of what I said about automating. Okay, let me go down the list. Okay, the recording deck will be shared, and I'll share links to anyone who attended the this presentation, the GoToWebinar, or the Past Data Science virtual group. And I hope to look to have more in the future. Oh, I missed part A of the question. Several decades ago, linear and integer programming was used to find the lowest cost of a maximum process. Has the technology replaced by AI? The answer is no. There's still so sorry, Bill, I cut your beginning of your question off. The answer to linear and integer programming is optimization, and optimization will still be important going forward. And in fact, I was on a team, and we had a solution mix between machine learning and then also optimization. So that is a whole science in itself. And I think as some of the data scientists who are on here, if you haven't seen optimization, look into it. Look into what people are doing with that. Okay, and I think that finishes our questions for today. We're now at 1:01 my time, and so glad to have so many people here. Definitely, right now, still have 130 people still hanging on to the end of the presentation. Thanks for staying all the way to the end. Again, you can, internal people in Microsoft, you know how to reach me, and you will be seeing my slides internally posted there, but also externally from Microsoft, we will have it in a publicly available site, and also with the video posted to YouTube. And so thanks. I'm going to stop the recording now.